Oh, hello and welcome to Special Problems with Mr. Bibsaw.
Yeah, we'll show you some special problems. You know how to do something like this, right? This is a trinomial with the first coefficient of 1, so we just do 8 and 6, and that would be 4 and 2. So we know how to do this one, x plus 4, x plus 2. But what if we change the exponents? Instead of x squared and x to the first, what if it's x to the fourth and x squared there? See, now it's a little bit different. How can we adjust our answer to make this work? And so if we start with this idea of, we know it's x plus 4, x plus 2, we need to think, what would I have to multiply the front numbers by to get x to the fourth? Well, that would be x squared times x squared. And if I FOIL that, x squared times x squared is x to the fourth. Check, that's what I want. Outers would be 2x squared. Inners would be 4x squared. And last would be 8. Okay, these add up to be 6x squared plus 8. So there we go, that's what we started with. So sometimes the trinomial method will work just fine, even if this is to the fourth and to the second. It just means that when we factor this, we're going to have to be careful to do that. Also, it might work if you had something like this. Okay. This can still work. It's just that this is going to be 4 and 2. It's just that the front number now is going to be x to the third and x to the third. So they multiply to be x to the sixth. So be careful about that. Now if there's an x on here, or an x squared on there, then it's different. It's not going to work. This number has to be a constant. If there was an x, I would do greatest common factor and probably be done. Okay? The other special problem I want to call your attention to is something like this. Oh wait, not x squared, x to the fourth. Okay, two terms. There's no greatest common factor. This is a difference of two perfect squares. This is a perfect square, that's a perfect square. So I can go to my answer. The square root here is x squared. The square root here is 4. One's positive, one's negative, and done? Almost done. But always examine the end of your answer to see, is there anything I can do with these? This is a perfect square plus a perfect square. This is a perfect square minus a perfect square. Wait a second, that's another difference of two perfect squares. This one here, we can keep going with. The square root of x squared is x and x. Square root of 4 is 2 and 2. One positive, one negative. So x squared plus 4, this one just comes down. This one could be factored one more step. So just be careful when you're looking at these. Sometimes we have an answer that part of our answer could still be factored a little bit more. And we want to make sure to factor it as much as we can. Have a great day.